firstly, we would like to know what is an algorithm. We need to define an algorithm, right? We said an algorithm is like when you do the cook, you know how to one step by one step to do the operations, and you know what materials you need. That is what data you need. You've got, and what data you need to do the operations, and what's the operations one step by one step. And you're supposed to know what's the resulting supposed to look like. So we could say an algorithm is a set of instructions. So as we talk about in our several previous class, we said a program is constructed by instructions. Anything in the computing system or in the computer, any options are controlled by the instructions. Do you remember? Our last assignment is to write the instructions to output your name on the computer. Do you remember your assignments that we need to write down the machine language, the binary strings to represent the instructions? So I've checked some of your assignments. Okay, so some of your assignments just list the ASCII number of your alphabet in your name, but that's not the full instructions. So if you need to control something, to operate something, you need a full instructions. The full instruction is supposed to include the three things. Firstly is the instruction mode, and secondly is the addressing mode. You need to know how to find your operand, and the third is what's the operand or where to find the operand. You need the operand code. So any instruction is supposed to be maybe 24 bits. So focus on that to modify your assignments, okay? So basically we say any algorithm, it is a set of instructions. What kind of instructions? It is unambiguous instructions. So what's these instructions for? They are used for solving a problem, okay? The main purpose of any algorithm is to solve a problem. Of course, it could be a problem or it could be sub-problems, because we said we always use divide and conquer concept in the computing system, in the algorithm design. You divide the big problem, a very huge problem, to several sub-problems and divide it again, divide until the smallest one and conquer it. So any algorithm could be solving a problem or a sub-problem. And the most important thing is it should be finished in a finite amount of time. Okay, that is quite important because you always hope your program finished within a limited time. And besides the limitation of your time, another limitation is you use a finite amount of data. Okay, so you don't need you don't want your algorithm process an infinite amount of data. So the time in the data is supposed to be limited. So an algorithm can be defined as a set of instructions to solve a problem or sub-problem in a finite amount of time using a finite amount of data. So we can divide it into two different algorithm steps. First one we call it abstract step. The second one we call it concrete step. What's the difference between these steps? The first abstract step represents an step in an algorithm which contains unspecific details. So it's up level in the abstraction viewpoint. And a concrete step is a step in an algorithm that all details are specified. Okay. So we have mentioned that to develop any algorithm.
So we are directly go to the algorithm part.
Is a computer can accomplish. So you need to know, firstly, you need to know what tasks could the computer can accomplish from the very fundamental viewpoint. So then you need to know how to solve your problems using these instructions, using these fundamental tasks, fundamental approaches the computer can do. You need to know how to construct these instructions together so that a problem can be solved, so that different programs or softwares can be developed, such as the Wolf meeting application we used, so that we can use this website or use this application through the internet, and all of you can join this class, or like our PowerPoint. So we can write things on this PowerPoint, and we can show different slides. So all these are programs, all these are softwares. How are they developed? They're based on some fundamental concepts, and they're based on some fundamental algorithms, and they use some design methodologies. But the most fundamental thing is how to control the computer one step by one step to accomplish your task. So the most fundamental thing is, firstly, you need to know what a computer can do. We have talked about a computer can process data, can retrieve data, can store data. So firstly, what can a computer do? And from the hardware, from the electrical circuit viewpoint, from the transistor circuit viewpoint, how the computer works and how the instructions are built based on these hardwares. And then how our human beings can control these instructions through programming. What kind of methodology we can use. All of these build up the programs or software. So you need to have an abstraction concept about all these layers from the top to the up level. Okay, so keep all these concepts through the abstraction viewpoint in your mind.